Although the first ever attempt to collect a Mars rock came up empty this week, we got a preview of how scientifically spectacular the sample will be. Perseverance has been investigating the lowest and therefore the oldest rocks yet encountered in a terrain dubbed Sita, Navajo for amongst the sand. The fractured bedrock, which looks like paving stones, is the target for the first of dozens of rock core samples that will be collected during the mission for future return to labs on Earth. In a lucky coincidence, this historic first will occur in a stunning landscape of Martian hills and outcrops. Some of these look layered, but as I presented in the previous episode, that may be due to fracturing and weathering processes. This slab of bedrock is the site of the first coring attempt. Here's a rock hammer for scale. The Masscam Z view shows a surface covered in a mix of dust, sand, and pebbles, nothing yet to get excited about. But the first order of business was to use the corer, here seen on the folded robotic arm, to grind down a few millimeters with the abrading bit. This gives a clearer view of what's underneath and creates a smoother surface that some of the instruments require. Because the grinding operation generates so much rock powder, the robotic arm also carries the gas dust removal tool. G-Dirt has a tank of pressurized nitrogen from Earth that it can blow out of the nozzle at supersonic speed. This sounds like overkill, but the gas expands so quickly in the thin Martian atmosphere that it doesn't damage the rock surface. Here's the front hazcam view of the corer with its stabilizers pressing down on the rock. You won't see the abrading bit in action, but the before and after views shows that it definitely worked. The view from the navcam after the grind shows the grayish rock powder piled up in a ring and covering the bottom of the hole. This is where G-Dirt comes in. It did a great job clearing out the hole and spreading the powder away from it. The arm-mounted Watson camera provided this great close-up view. Here's a quarter for scale. This is the first clear look we've had at any of the rocks in Jezero Crater, and to a geologist it's pretty spectacular. The first thing to notice is all the different colors. The reddish-brown could be evidence of water rusting iron-rich minerals. The dark greenish-gray bits could be the volcanic mineral olivine, recognized in orbital observations. But it's the whitish areas that are the most exciting. These could be the carbonate minerals also recognized from orbit. An extreme close-up from Sherlock's camera shows the very irregular shape of the white stuff, like it came in after the rock was formed. Sherlock was designed to identify minerals at this scale, so we'll know whether this is carbonate. With a sample of this rock back on Earth, isotopes from carbonate could even tell us the temperature of the water it formed in, so maybe we could know the temperature of ancient Lake Jezero. But first we've got to collect a sample. This navcam view shows the coring bit, a technological marvel that holds a sample tube inside. It was used for the first time this past week to drill a hole, in this case right next to the grind spot, to allow both the weathered surface and interior to be sampled. It's clear from the pile of rock powder that the coring operation went as planned. But the view from Masscam Z inside the coring bit shows that the core was not extracted. One possibility is that it didn't snap off at the bottom, a challenge for any coring operation. Hundreds of tests of this system were successful on Earth, so it may take a few attempts to get it right on Mars.